Application of first-order differential equation in electrical circuits for RC circuits. Submitted by Aldrin Paule Jr. from BSEE 2C. Today, we're going to talk about the application of first-order differential equation in electrical circuits for RC circuit. RC stands for resistor-capacitor circuits. Let's look at our circuit here. We have the voltage source E, resistor R, capacitor C, and the switch, all connected in a series. Our differential equation for this application of DE is equivalent to R, which is the resistance in ohms, the change in charge with respect to time, plus Q, the charge in coulombs, over C, which is the capacitance in farads, all equivalent to E, which is the voltage source. Remember, current is equal to change in charge with respect to time. Let's try to solve a problem. In a series RC circuit, R is equals to 5 ohms, C is equals to 0.01 farad, and E is 100 volts. When time is 0, the current is 0. Find the charge at any time t. What are the given? Resistance is equals to 5 ohms, capacitance is 0.01 farad, and voltage source is 100 volts. We need to find an equation wherein we can find the charge at any time given or any time t. We should write again the equation R dq over dt plus q over c is equals to E. We substitute the given to the equation. We will have 5 dq over dt plus, we don't have the q because q is changing in terms of time, so q over 0.01, which is the capacitance C, equals to 100. Let us divide both the sides of the equation by 5. We will have dq with respect to time plus q over 5 times 0.01 is equals to 20. We will be having 1 over 5 times 0.01. It will become 20 also if we are going to calculate. We will now have dq over dt plus 20q is equals to 20. We have a linear in terms of q, so we have to solve this differential equation by QE raised to 20 integral with respect to time, equivalent to integral of 20e raised to 20 dt with respect to time. Let us now evaluate. Q e raised to 20t is equal to, we can factor out 20 for being constant. Integral of e raised to 20 dt is e raised to 20t and dt. We need to evaluate the integral. Let u be equal to 20t, du with respect to t is equals to 20 dt. Therefore, du over 20 is equals to dt. We can now perform the u substitution. E raised to 20t, which is u, and dt equivalent to du over 20. Factor now 1 over 20 outside the integral. We have 20 over 20, which is equals to 1, e raised to u du. Back substitute the value of u. We have q e raised to 20 is equals to e raised to u, which is 20t as c. Let us now express this in terms of purely q. Divide both sides by 1 over e raised to 20t. We will now have q is equals to e raised to 20t over e raised to 20t, which will be cancelled, plus c over e raised to 20t. We now have 1 plus c over e raised to 20t. Can we get how the charge at any time? No, we don't have the value of c yet. To find the c value, we need to apply the initial conditions first. When time is equal to 0, current is equal to 0. Because of this, we can conclude that there is no charge. Charge is also 0. We have 0 is equals to 1 plus c over e raised to 20 times 0, which is equals to 1. We have c is equals to negative 1. Let's go back to this equation. Let us substitute C value. We will have Q is equals to 1 minus 1 over E raised to 20t. This is our equation to find the charge at any time. Because if you are going to substitute the value of t, we can always get the charge. I hope you learned. That's all and thank you.